All right. So this lesson is going to be as short as I can make it. Y'all shut your computers. Everybody at home, don't shut your computer because you're watching me. Big Bohr models, okay? So far, we've just reviewed what you probably knew when you came into this class, and that's how to do the simple Bohr models 1 through 18. Well, they get a little more complicated, all right? If you look at the periodic table, you can see the periodic table obviously goes much further than 1 through 18, right? The periodic table, and the part that we've been studying on the periodic table so far has just been these top 1, 2, 3 periods, okay? But once you get down to period 4, then you have to deal with the middle of the table, okay? And then once you get down to period 6, you have to deal with the 2 parts of the table in the middle, the inner transition metals and the regular transition metals, right? So what we're going to do right now is understand how you can see these numbers over here for krypton being 2, 8, 18, and 8, all right? These numbers, so far, you've only been able to put 8 dots, right? Now we're going to learn how to put more dots on the Bohr model, okay? And the reasons for this are fairly complicated, and I'll explain them really more later when we start talking about some more technical models of the atom, okay? So right now, I'm going to show you the periodic table, okay? And I'm going to try to, over here beside of the periodic table, okay, right here, making sure this is on the screen, I'm going to try to model something right here. I tell you what, see if I can, I wonder if we can write on here if you can see that. Let me see. I'm looking on the screen. That ain't that great. All right, here we go. Let's say we wanted to model this atom right here. We'll call it chromium. Chromium, everybody. Everybody remember chromium? It's number 24 on your periodic table. If we were going to try to do a Bohr model of chromium, right, then we'd be building a regular model. Here's here's period 1, here's period 2, here's period 3, here's period 4, okay? Now for us to do chromium, we start out with a model looking like we've always done. The first circle will have 1, 2 dashes on it, right? So here's our inner circle. Just making sure this fits on here. 1, 2, so that takes us up to helium. And then here's our second ring, 1, 2, 3, 4, 5, 6, 7, 8. This takes us to neon, 1, 2, 3, 4, 5, 6, 7, 8. So that's neon, and this is neon so far, right? Right? Does that make sense? Okay. Then now, we come down here to sodium, and we move across period 3, and that takes us to argon. 8 more, 1, 2, 3, 4, 5, 6, 7, 8. And now we're down here in the 4th period. So we're obviously going to need to have another circle, correct? Right? Going to need to have another circle. So here's our next circle. This is our 4th circle out. It's pretty big. 1, 2. That takes us to potassium and calcium. And then now things change. Once we get here into the middle, into the transition metals, we stop doing what we were doing. So far, our Bohr model that we've drawn, meant to do that, all the way up, this is all the way up through calcium. Calcium would be 2, 8, 8, and 2. And those numbers would add up to 20, right? Isn't calcium number 20 on the periodic table? Right? Okay. So this has gotten us, that regular looking Bohr model right there has gotten us to calcium. Okay? But now once we get past calcium, we're in the transition metals, right? And once we hop into the transition metal areas, these in the transition metals, the dashes that we put for scandium, titanium, vanadium, and chromium, these four actually go up here in the third period, or when we're drawing it on our Bohr model, the last four that we add for, and I'm going to make them X's, for scandium, right? Titanium, vanadium, and chromium, they actually go one circle in. So if I was going to label this Bohr model, with the numbers, right? With the numbers, then the numbers would be 2, then the next ring out is 8, then the next ring has 1, 2, 3, 4 extra, 12, and then the fourth ring has 2. Those would be the numbers for chromium, okay? Does that make sense? Let's try another one, right? Let's try another one. I'm going to, and if you're at home, people, if you're at home, rewind it. Watch it again. Skip backwards. Try it, right? Do it backwards. All right? Here we go. Let's try another one. Let's try to do a Bohr model for, who we got right here? Who is right here? Copper. Copper. All right? So we're going to work our way to copper. All right? So the first period, how many squares are in the first period? 2. So over here we're drawing a Bohr model. 1, 2. That's helium. That gets us to right there. Now our next circle is going to have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Our next circle is going to have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And then we're down here to the fourth period. 1, 2, 3, 4. The fourth period, or the fourth circle, right? Small circle, bigger circle, bigger circle, bigger circle, right? Fourth period, we go to these first two. Boom, boom. Potassium, calcium. That's our fourth one. Boom, boom. And then now once we get in here to the middle, to the transition metals, once we're in here, all of these fit in one ring. Or in other words, all of these act like they're up one on the periodic table. Okay? So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. And those 9 don't go out here in the fourth ring like you would think. They go here. 1, 2, 3, 4. Notice I'm spreading them out. 5, 6, 7, 8, 9. So let's do our numbers. Let's do our number for this model we just built. We just built this model right here. 2, 8. We've got 9 extra here. So 17 and 2. That's going to be copper. Let's check and see if we're right. 2 plus 8 is 10. Plus 17 is 27. Plus 2 more is 29. Is copper number 29 on the periodic table? Yes. That's how you know you're right. Okay? And for everybody at home and for y'all, I'll do one more as quickly as possible because I see that this is now taking 10 minutes. One more as quickly as possible, right? Super fast. I'm going to do one that's even bigger. Here we go. let's choose a bigger one. How about we do this bad boy right here? I'm going to say that is ruthenium, or we'll do palladium. How about this? This is palladium, right? Am I on the right spot? Okay, let's do a Bohr model of this bad boy. Okay? Boom. First ring, it's a small circle. Boom. Boom. It's got 2 dots in it, right? Count. Second ring, period 2, slightly bigger circle. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Third ring, it's the bigger circle. 3, period 3. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Fourth ring, it's even bigger circle. 1, 2. Fourth ring. 1, 2. Now we're here in the middle. These in the middle act like they're really up in the third group, right? Or in other words, they go in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then now when we get back over here, and we're in the tall rows again, right? Then we go back out to the outside. So when we get right here to gallium, now we're going back, and we're going to put these right here. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, right? So that gets us to, where are we at right here? Neon, argon, who's next? Krypton, right? We're at krypton, so if we stopped here, krypton would be 2, 8, 18, and 8. And if you notice, that is what's written right there on the periodic table for krypton, 2, 8, 18, and 8, right? And then now we're going to come back over here, and we're getting our way to palladium. So now we're in, this is period 4, now we're in period 5, an even bigger circle, right? Bigger circle. 1, 2, these first 2 go on the outside. 1, 2 on the outside, and then now we're back here into the middle, and these act like they're really in the 4th circle. These are up arrows, right? So I've got 1, 2, 3, 4, 5, 6, 7, 8 that I add to the 4th circle. 1, 2, 3, 4, 5, 6, 7, 8. So now that messes us up. We added 8 more. 1, 2, 3, 4, 5, 6, 7, 8. That takes us to, this 8 changes to what? To 16. And then we got 2 more in the outer shell. So 2, 8, 18, 16, and 2. Let's see what these numbers add up for. 2 plus 8 is 10. 28, right? 28 plus 16 is 44, 46. Let's see what palladium is on the periodic table. It's number 46. That's how we know we're right. Does that make sense to you? Okay, we'll try some of these for practice. People at home, good luck. We'll try some more.